Welcome to the intersection of technology, cybersecurity, and society. Welcome to ITSP Magazine. You're listening to a new episode of Stories from Space podcast, where your host, Matthew Williams, examines the history of human spaceflight, the breakthroughs that revolutionized our understanding of the universe and our place in it, and the brave individuals who work tirelessly to advance the frontiers of our understanding. Knowledge is power, now more than ever.
The authors acknowledge that this podcast was recorded on the traditional, unceded lands of the Lekwungen peoples. Hello, and welcome back to another episode of Stories from Space. I'm your host, Matt Williams, and today we're going to be taking another look at how humans may settle the solar system someday, or what is typically referred to as the Great Migration, humanity venturing beyond Earth and establishing settlements throughout the solar system. In previous episodes, we looked at how human beings could eventually establish outposts on the Moon, on Mars, on Venus, and Mercury, eventually leading to segments of humanity known as Loonies or Selenians, Martians, Cytharians, and Hermians. And today, keeping up with our progression, we're going to look at the Main Asteroid Belt. With the right strategies, techniques, technology, and know-how, could there be a segment of humanity someday that comes to be known as the Belters? Fans of the Expanse series will recognize that one right off the bat. Then again, fans of just about any science fiction franchise ought to recognize this idea. It's been explored extensively in science fiction and, of course, also as a matter of scientific proposals. The idea that human beings would establish a foothold in the asteroid belt is part of the Great Migration theory, that once we have established ourselves in the inner solar system, we'll begin to branch out towards the Jovian system, the Cronian system, that is to say Jupiter and Saturn, and that the asteroid belt would serve as an important stopover point in between, where we could not only establish countless human habitats, but massive mining and manufacturing concerns where we could harvest a virtually inexhaustible supply of precious metals, rare earth metals, volatiles such as water, ice, ammonia, and methane, and where large-scale settlements could be built on the larger bodies such as Ceres and Vesta. And all that material wealth would essentially fuel this whole drive towards a post-scarcity economy. There's also the benefit of planetary defense. As Robert Zubrin explained in his book Entering Space, Creating a Spacefaring Civilization, Earth has been struck by asteroids that generated enough force, enough power, to cause mass extinction events. The Earth has also received countless impacts of smaller size that led to widespread destruction that was more localized, but still very devastating. By establishing a presence in the belt, we would actually be able to detect, intercept, and redirect asteroids long before they threaten Earth. And if we assume that we have already established settlements on the Moon and Mars at this point, well, the same holds for them. So the question then is, how could we do it? What would it take to put humans in the asteroid belt and create a thriving outpost of civilization there? Well, the challenges are pretty simple. Foremost, there is the distances involved, which makes transits there and back rather lengthy, rather difficult. In other words, time-consuming and expensive. There's also the matter of there being no natural celestial bodies in the belt that have an atmosphere. So there would have to be protection against the elements in the near vacuum of space. And of course, there's also microgravity. For the vast majority of bodies in the belt, the gravity is so low that it's practically like being in free space. Even Ceres, the largest, most massive body in the asteroid belt, the gravity on the surface is about 3% that of Earth's. So the long-term effects of that, as we know from studying the effects of microgravity in the human body aboard the ISS, are muscle degeneration, bone deterioration, diminished organ function, eyesight being affected, circulation, your cardiovascular system, nervous system. They all are impacted. Even gene expression is impacted. Furthermore, there's the question of radiation, whether or not enough sunlight reaches the belt for there to be any kind of solar power. So for human beings to establish outposts in the belt, it kind of goes without saying that anyone there would be leaning on their technology pretty heavily. They would be highly dependent upon their manufactured environments, and they would require power sources that were renewable, sustainable, and could provide abundant energy that would supplement any kind of solar or fuel cells or any other type of power generation. And just getting there and back in order for it to be economical and not incredibly time-consuming. And of course, these two things go hand in hand. We would need advanced propulsion, something that could bring payloads and people to and from the belt within a matter of weeks, not years. Fortunately, there's plenty of time to wait on those advancements to happen, mainly because establishing a settlement in the asteroid belt would not be practical or feasible until we've established a settlement on the Moon, on Mars. Basically, it will become feasible and become worth our while once we've already become a multiplanetary species, and that massive belt of rocks and abundant resources is just the next step. And much of the technological challenges are the exact same for settling on those two bodies. As we discussed in a previous episode, nuclear thermal or nuclear electric propulsion, or a combination thereof, bimodal nuclear propulsion. This is something that would make regular missions to Mars a reality. It would make them entirely cost-effective, and it could be done in as little as 45 days. And so, something along those lines would also be needed for the asteroid belt. Reaching the belt would be more time-consuming than heading to Mars using that technology, but we can realistically assume that after nuclear thermal, nuclear electric, the next step is going to be fusion propulsion. And this would likely consist of deuterium pellets being fused in a reaction chamber many times per second to provide a tremendous amount of thrust. And this could allow spacecraft to accelerate to a point where they could reach the belt in just a few weeks. Traveling from Earth, traveling from Mars, it'd be even quicker. Once there, automated robots or construction crews, they'd have abundant materials to work with that could be harvested on site, otherwise known as in situ resource utilization, which could provide for all the construction and building material needs they have. So habitats could be created on site using only locally sourced materials. Therefore, missions headed to the belt could really save on weight, on payloads. All they'd really need to bring along is the necessary robots and 3D printers for manufacturing these facilities, and of course whatever crew they intend to bring. Nuclear power is also likely to be the mainstay when it comes to providing energy in the belt, and this could take the form of Stirling reactors, basically reactors that use the slow decay of uranium or plutonium to power Stirling engines, which basically steam through turbines, pumps that are able to generate electricity sustainably over long periods of time, or better yet, tokamak reactors, fusion reactors that run on helium-3. And the reason for this is because solar energy is limited in the belt. Mars receives roughly half the same amount of solar energy as the Earth does, and the belt, it's even less than that, unfortunately. So while solar arrays would be an option there, you could place plenty of space-based solar arrays in and around larger bodies in and around habitats to provide energy. It's likely you'd need a reactor to provide backup power. One advantage to solar in the belt is that it's not at all perennial. It has the same benefits as space-based solar here on Earth or on any other celestial body. It can collect power 24/7. It's just going to be somewhat limited at that distance. And once again, that requires future advancements to take place. If we're talking about Stirling reactors, that's something we can build today. It's something that NASA is currently working on, in fact, for missions to the Moon and Mars. Tokamak reactors made miniature, that is something that is also in development right now. That will take time for that technology to mature, but as I said before, If we've already established settlements on the Moon and Mars, then chances are that technology has matured fully and is probably already in use. And what's more, an attractive thing about having a foothold in the belt so that you can send missions out to the gas giants, these could scoop up helium-3 in abundance from Jupiter's atmosphere and bring that back so that you've got a steady fuel supply. So between nuclear propulsion and nuclear power, the belt would be not only accessible, but habitats and heavy industry, mining, and all these things could be located there and sourced there. And the next step is, of course, habitat construction. And one of the best aspects of building in the belt is you don't need to build habitats on the surface. In fact, as we explored in previous episodes about settling on the Moon and Mars, a long-term strategy for dealing with the lower gravity is to have pinwheel stations, or rotating stations, in orbit, where people can go and spend time in a simulated gravity environment where the station spins to simulate 1g of gravity, so Earth normal. In the belt, you could build similar stations, and these would be the habitats. They could sit in orbit around Ceres and Vesta and any of the larger bodies, and share the belt's orbit around the Sun, and these would provide all the living accommodations that would be needed, and of course the resources of the belt could be used to sustain them. In addition to all the metals and silicate minerals, you also have extensive amounts of water ice and volatiles, and these could be imported into the station to create a biome inside them. Because the only way a human presence is going to be sustainable in the belt is if there are bioregenerative life support systems. So we're talking about an interior space with grass, with trees, with all forms of terrestrial animals, with different types of climates being simulated. And this will allow for the entire system to renew itself and replenish itself over time. The air gets scrubbed clean of excess carbon dioxide, oxygen is produced, water is cleaned. Water has a cycle where it will precipitate. It'll evaporate from standing bodies of water on the ground and form clouds, which then release rain. And all the while you'll need simulated sunlight. So a very good idea is to have solar mirrors, which reflect and concentrate light from the sun into the habitats, simulating a night and day cycle. And another option is to not build these habitats in space, but in fact, to find asteroids that are cylindrical or just the right shape, and then hollow these out, build your natural biomes inside, and then once they're spun up, they're able to simulate gravity for the inhabitants the same way a station would. And this idea has been explored extensively by science fiction writers and scientific theorists. In fact, to use The Expanse as an example, in that series, there is a large human presence on Ceres. And as was explained in the novels, the idea with Ceres was that the settlement was actually built on the inside of the planetoid. It was nestled up against the outer crust. It was oriented so that it was basically facing inward towards the center of Ceres. And then they spun up the body so that it would simulate 30% Earth gravity. So the Belters, of course, they're still living in lower gravity, and this is the reason for their various physiological quirks, the reason why they cannot withstand Earth normal gravity without significant difficulty, but it is significantly greater than microgravity. Another good example is Kim Stanley Robinson. In his book 2312, he shows how people live in not only the Main Asteroid Belt, but in any large asteroids throughout the solar system. Any of those that had the right shape were hollowed out and spun up, and people were able to frolic in these interior environments with all kinds of genetically engineered organisms and animals. And Ben Bova also explored the idea as part of his Grand Tour series, which deals with a future in which humanity has settled all throughout the solar system, and individual novels talk about specific locations. And Robert A. Heinlein, in his 1939 short story, Misfits, it also spoke about how asteroids could be transformed into space stations or habitats. Now, in terms of the actual amount of mineral wealth that could be extracted from the asteroid belt, well, it's difficult to place any accurate constraints on, but a number of estimates have been made about the amount of wealth that could be extracted from a single asteroid. One of which was done by famed scientist and science communicator Robert Zubrin, who wrote a 1987 book, Space Resources Breaking the Bonds of Earth, which he co-authored with Professor John Lewis and Ruth Lewis of the University of Arizona, two cosmochemists, and they considered a single S-type asteroid, which are so designated because they're predominantly made up of silicate minerals, and they found that a single asteroid measuring 1 kilometer in diameter, or 0.6 miles, would weigh as much as 2 billion metric tons. And of that, there would be 7,500 tons of precious metals alone. That's not even counting the over 200 million tons of iron, nickel, and cobalt. And based on their estimates, and adjusted for inflation, the value of the precious metals alone comes out to $371 billion. And if you add up the current market value for all the metals that this asteroid would contain, it comes out to over $2 trillion. And another estimate was made by Richard Bartlett, a former columnist for Astronomy magazine, who said that even a small S-type asteroid, one that measured just 10 meters or 33 feet in diameter, would contain as much as 50 kilograms of precious metals like platinum and gold. And based on its current market value, 50 kilos of platinum is worth over $1.5 million, whereas gold is worth over $3 million. And that's just from an asteroid measuring 10 meters in diameter. When you consider that there's an estimated 1.1 to 1.9 million asteroids in the belt that measure larger than 1 kilometer, well, that's quite the dollar sign. And that's not even taking into account asteroids in the belt which are predominantly composed of metal, the largest of which is the body 16 Psyche, which NASA recently launched a mission of the same name, the Psyche probe, to explore. And it is scheduled to rendezvous with this body by August of 2029. And what's especially fascinating about it is that, as far as astronomers can tell, it is a giant ball of iron and nickel, quite possibly the core of a planetoid that formed in the belt, but which suffered a massive collision which caused all of its silicate outer layers to melt and blow off. And there have actually been attempts to estimate how much this ball of metal would be worth. And the less conservative one said as high as 10,000 quadrillion. That's 1,000 followed by 15 zeros, or 1 trillion trillion. Now, of course, the idea is not to mine out all this wealth and ship it all back to Earth, but by tapping just a small bit of that, we could actually put the majority of the asteroid belt aside as a sort of nature preserve, just maintaining it in its current state and not disturbing it, tapping even a tiny percent of the wealth's metal, turning it into manufactured goods or bits and pieces for components. This would trigger a post-scarcity future. Basically, precious metals would no longer be precious. They would no longer be so unbelievably expensive. Literally, any type of metal would become so very abundant in terms of our market resources that wealth itself, the very basis of wealth, would disappear. We're talking about a great leveler. And far more than just wealth, there's the possibility of scientific research and the way in which creating just endless settlements in the belt could lead to all kinds of sociopolitical experimentation, cultural experimentation. And to quote Robert Zubrin once again, what he said in Entering Space about settling the asteroid belt in particular, he emphasized how human beings could create countless societies in miniature to test out various political and social philosophies. He said, "This will make available thousands of potential new worlds whose cultures and systems of law need never fuse. Perhaps some will be Republican, others anarchist, some communalists, others capitalist, some patriarchal, others matriarchal, some aristocratic, others egalitarian, some religious, others rationalist, some Epicureans, others puritanical, some traditional, others novel. For a long time to come, groups of human beings who think they have found a better way will have places to go where they can give it a try. The rest of humanity will watch and learn from their experiences. That is perhaps a tad optimistic, but it would lead to some very, very interesting cultural patterns. Another interesting possibility is that the belt could offer endless opportunities for cultural preservation. Because if there's one thing that often tends to be the case with human history, it's conquest and assimilation and the destruction of cultural traditions and heritage because of imperialism and genocide and just the process of cultural integration itself, when done peacefully, can often mean that certain traditions, certain practices are lost along the way or pushed to the side, denied or forgotten simply because they weren't part of the global culture that emerged. So the belt, having endless settlements there, this could be a way of ensuring that certain cultural practices don't die or of resurrecting ones that have been lost over time. In that respect, it's like no matter what happens on Earth, we know that our people and our way of life and our beliefs and our practices will carry on because we've seeded the cosmos with them. And as I mentioned, the potential for scientific research is also great because, as scientists have learned, asteroids are essentially leftover material from the formation of the solar system. So by studying asteroids, and this is a major aspect of NASA and the ESA and other space agencies, their research programs looking to the future, the study of asteroids, whether it's in the Main Belt or the Kuiper Belt, which are more properly defined as asteroids, and also Trojan asteroids and Greek asteroids around Jupiter, and of course the ones closer to home, near-Earth asteroids. All of these present opportunities for examining material that has been carefully preserved in the vacuum of space for billions of years, dating to the very formation of the solar system roughly 4.5 billion years ago. So it's like basically taking a snapshot, and it creates the opportunity to create a more complete geological record of our entire solar system, to learn more about its formation and its subsequent evolution. But of course, the challenge is, right? Getting to the asteroid belt, getting people there, getting the necessary robots there, harvesting local materials in order to build all this infrastructure, creating an economy and allowing for this cultural, political, sociological experiment and blossoming to take place. It represents a major, major undertaking. And as I've said repeatedly now, one of the beauty parts of it is that this is not a leap that we need to make from right here from Earth. Rather, it would be a matter of steps. First, orbit and cislunar space, then to Mars, and then to the belt. Meanwhile, similar efforts are likely to extend into the inner solar system, Venus and Mercury. The point being that by the time human beings, or if and when we do reach the belt with the intent to not only explore it, but create an enduring human presence there, we will at least have the requisite technology. As for the rest, the major undertaking, the commitment, which would, again, be a multi-generational commitment, several generations of people would come and go before the belt becomes its own thriving sector of human civilization, before there is such a thing as belters. But it can be done, and that's the point. And the end result of it would be incredibly fascinating, very, very exciting to study, and it would set the stage for further growth, further extensions of the human exploration and human presence in the solar system, beyond what's known as the frost line, the boundary beyond which volatiles like water, carbon dioxide, carbon monoxide, methane, ammonia, etc., the boundary beyond which these will be frozen solid, and any bodies that form beyond this boundary will be composed largely of ice. Or, in the case of the gas giants, gases that have become liquid or even solid because of temperatures and pressures. But we'll talk about that more next time as we get into the subject of how human beings could settle the satellites orbiting gas giants, starting with Jupiter, then Saturn, Uranus, Neptune, and then the outer solar system, the trans-Neptunian region, the Kuiper Belt, and all those quote-unquote minor planets out there. thus completing our tour of the solar system and where human beings can hope and expect to settle someday. In the meantime, thank you for listening. I'm Matt Williams, and this has been Stories from Space.
We hope you enjoyed this episode of Stories from Space podcast with Matthew Williams. If you learned something new and this podcast made you think, then share itspmagazine.com with your friends, family, and colleagues. If you represent a company and wish to associate your brand with our conversations, sponsor one or more of our podcast channels. We hope you will come back for more stories and follow us on our journey. You can always find us at the intersection of technology, cybersecurity, and society.